And here we go.
All right. Let's give it a minute or so because I see people are still pouring in. All right. I think we should get started. Good afternoon, everyone. My name is Sarah Fatima. I'm also moderating the call today. And thank you for joining our webinar about the wonderful world of cognitive services with TJBot. I'd like to introduce you to our speaker today, Victor Dibia. He has a very interesting title, Human Agent Collaboration Lab with IBM Research. So we'll let him explain what that means. But without further ado, I'd like to turn it over to Victor.
Hi, thanks. Hi everyone, my name is Victor, and today I'll be talking about a project that we've been working on over here at IBM Research Yorktown. I work with a group called the Human Agent Collaboration Lab at IBM Research. We used to be named the Cognitive Environments Lab. And essentially, we care about designing all kinds of interfaces and scenarios in which a human interacts with a machine or some kind of cognitive agent to perform an action. So essentially, we look at the interaction between man and machine and the various ways in which a machine can assist the person in the decision-making process. It's a lab full of people with different skills. We have people from psychology, math, and a bit of physics and cognitive modeling background. But today I'll be talking about the TJBot project. So essentially, it's an open source DIY project powered by Watson Cognitive Services, and I'll get a little bit more into that as we proceed. I've been told that most of the participants for this talk would be interns also who are participating in the BlueHack hackathon, and hopefully some of the things probably won't take the entire time. I'm hoping that we'll spend most of the time asking questions, clarifying, and for those who already have access to TJBot, if you have any issues, this could be a great time to discuss more on that. So today's talk is going to cover a few things: why TJBot, how Watson services enable TJBot and enable the different interactions we have in TJBot. And then I'll go through the different steps that you need in order to set up your TJBot. When you get the kit, there's a Raspberry Pi inside, there's an SD card, there's a bunch of sample code. How do you get all of that started running? And then I'll walk through one of the sample recipes we have. And then we can use the remaining time to have questions and have answers. So just to most of you might already know that at IBM that we do have a strong focus on cognitive technology, and most of this has started with the work that's been done with Watson and Watson's appearance on the question answer game Jeopardy. So essentially there we demonstrated that a system, we could build an AI technology that's capable of learning, capable of reasoning and understanding natural language at a level that's really, really similar to what a human being can do. However, the idea is that when people think about all of this, they're really interested, they're curious about it, and there's all this really good potential for technology like this to affect different domains, healthcare, elder care, education, and different other fields. However, people when they think about Watson, they think about a really complex algorithm running on complex machines, running on complex servers. And they think about it as thousands of lines of code. And essentially, when they think of the process of actually building their own applications to take advantage of this, they might think of it in terms of it being a really complex or difficult process. So essentially, over here at the lab, we kind of thought about can we build a system? Can we build tools that would take something that's perceived as tedious interaction, and then transform that to something that's much more approachable, much more interesting, and so a kind of interesting and preferred interaction. So the picture you see here is a workshop that we ran a couple of months ago, I think in March. And essentially, we had a group of people, a diverse group, designers, marketers, guys from sales, and we kind of like walked them through the process of actual building the bot and then connecting that to IBM Watson services and IBM BlueHack, and then interacting with the bot. So when you TJBot can be built in two ways. You can either 3D print it, which is the image we have on the left, or you could build it out of a piece of laser cut material. And I don't know if you can see my camera, but this is what that piece of laser cut material looks like. And I think for those participating in the hackathon, this is what you guys will get. It's got a bunch of different pieces, about 15 different components, which you can pop out, fold, put a bunch of electronics on the inside, and then you could actually build the bot. And it's got a few components. This little video just shows how these different components come together. So first of all, the most important component on the kit is the Raspberry Pi. I think most of you might be familiar with that. It's a credit card sized computer. It runs a version of the Linux operating system. It's pretty powerful. I think it has about 2.4 gigahertz of processing capability. And usually it comes with an SD card and a Raspberry Pi operating system. The other important components are the servo motor. It's because TJBot has a little arm that can be moved around, and that's controlled using the servo motor. It's got an LED light on top. It's a multicolor LED, RGB LED light. So essentially, you can use that to represent the state of the bot. And there are some examples which we have to show how we use the LED to represent different states on the bot. It also has a microphone, so essentially you can do speech-to-text recognition using the bot and build applications that have a voice-based user interface on top of them. It also does have a camera in front of it, so the robot has two eyes, and the camera just sits right in front of one of the eyes. And the interesting part is that you can take advantage of this and do a bit of vision recognition processing on the bot and prototype vision recognition-based applications using the bot. It also does have a speaker, so essentially you can do text to speech and then play different audio sound and all of that. So these are the most important components on TJBot, and they all come together to make a really pretty interesting tool, and on which you can prototype different applications. So what is TJBot? There are a few interesting things about the project. The first interesting part about it is that it's constructivist, it's hands-on. It starts out as a flat piece of laser cut cardboard, which you can fold and build yourself, assemble a bunch of components. And there's all this research that shows that actually building and constructing a kit has a ton of benefits in learning, in education, in engagement. And the other interesting part of it is that the project is simple and approachable. So essentially, we simple in the sense that all of the hardware parts, they can be built without the need for any kind of soldering or any kind of tape or adhesive. And you can just snap these different pieces together and build the bot. The other interesting part of it is that it's the programming language for coding all the different functions of TJBot are all done using JavaScript. So we've written some Node.js sample code that shows you how to do most of that. The third important and interesting piece about the project is that it's open source. And by this is we refer to both the code and the design files. So for example, if you do have access to a 3D printer, you could download the 3D design files for TJBot. You could 3D print one wherever you are. And also, if you do have access to a laser cut machine, you can download the laser cut design files and also laser cut a piece of that. We have a bunch of sample code on GitHub. So essentially, you can take that, you can extend it, you can remix it, you can modify it to suit your own problem domain and use cases. The next interesting piece about TJBot is that there's a bit of a cognitive focus here. So we've shown examples of how you can connect TJBot to a bunch of different IBM Watson services, starting from the most simple things like speech-to-text, text-to-speech, and going to the more interesting things like conversation, which is IBM's technology for designing chatbots. And then going on to things like IBM visual recognition for understanding concept reading and image. And then also the IBM weather service and the IBM natural language understanding service. And finally, TJBot is extensible, so you can add additional hardware sensors to it. The Raspberry Pi is an extensible programming platform, prototyping platform, and you can add all kinds of different sensors, temperature sensors, pressure sensors, light sensors, gas sensors, if you're so inclined. And essentially, you can also connect to third-party services on other online APIs. So how does Watson enable TJBot? So for example, the function, there are a couple of capabilities that the bot has. So for example, it's able to listen, and essentially that's enabled by Watson's speech-to-text. Audio comes in from the microphone, and that's sent through a stream directly to the Watson speech-to-text API and Linux. Then we get text transcript back, and then we can process it, and that's how TJBot is able to listen. For it to speak, it's again something similar. We use the IBM text-to-speech service, so we send that to a bunch of text, and then it synthesizes an audio clip, which is then downloaded and played through the speakers. And TJBot is also able to understand emotions. So, for example, as a person starts to speak with the bots, it could transcribe their voice, their speech into text. And then this text can be sent to the Watson tone analyzer service, which lets the bot know if the person it's interacting with is becoming happy, excited, angry, or sad. And then you could also ask TJBot things like, "What do you see?" And it will take a picture using the camera in its eye, and then it will also upload that picture to the Watson visual recognition service, which will then return a set of tags that describe the content of what the picture is. And then, in similar vein, you could prototype complex multi-turn conversations using the IBM conversation service. So what was the goal of this project? When we built this so that as an experiment to understand if we simplify the process of creating cognitive applications sufficiently, and we make it interesting and approachable, what are the kind of things that people are going to create? And we targeted a few groups of people, students. So one way is for it to be an education and learning tool. It could be, I mean, and this could be for a wide range of students, high school students, college students, and for high school students could be a really interesting way to introduce them to concepts in computer science and artificial intelligence. There are also applications for TJBot for individuals who are non-technical or within other fields, like the guys in the sales area or marketing area. It's also a great way for them to get hands-on experience with programming cognitive services. And then for developers and makers, there are groups of them that are really familiar with things like web application development, database application development, but they haven't really got into cognitive and natural language interaction. And this is a great way for them to participate in this type of development. Also for makers, these are groups of people who are they're really competent with hardware, circuits, logic programming. However, what's missing in their design portfolio are things related to voice-based interaction, natural language interaction, vision recognition, and gesture recognition. So a project like TJBot is a great way to onboard all these different target audiences to prototyping and creating cognitive applications. So far, we've used a couple of platforms to disseminate the project. The first being GitHub. We've put out a bunch of sample code in JavaScript, with Node.js, and essentially the sample code shows you how you can do basic things like perform speech to text on the robots. For example, we have a sample called the speech to text demo, where you could run it and tell TJBot, turn the lights on, turn the lights off, or turn the lights green or yellow, and it will respond and control the LED lights that's on its head. We also have some other demo where you could connect TJBot to Twitter and get it to listen for keywords around tweets around a particular keyword. So for example, you could listen for tweets around IBM and then continuously compute the sentiment behind IBM in real time. So for example, the sentiment within the tweets about IBM was happy, it will turn its LED to yellow. If it was sad, it will turn it to blue. If it was angry, it will turn it to red, and so forth. And we also have a final sample that shows you how you could create a simple or complex conversation flow on using the IBM conversation API, and then connect that conversation flow to TJBot and have a voice-based interface on top of that. So essentially, as opposed to chatting with a bot online on the web page, you could actually have a conversation, a voice-based conversation with the bot. The other way in which we've disseminated this project has to do with some of the material we put on Instructables. So Instructables is an online maker platform. It's one of the largest online maker platforms in the world with about over 30 million users. And we've created step-by-step instructions, images, text, video that show you how you could, starting with just folding the cardboard piece to actually assembling the bot and actually running the different sample code recipes that we've put out there. And below at the bottom of this slide, there were some of the most important links, resource links that you need to have. ibm.b/mytjbot, which is the project homepage. And the other interesting link is the link to TJBot on the Instructables platform. For those who are interested in obtaining one, we again on the project homepage, ibm.b/mytjbot, we actually have some links to different places where you could purchase either different components that comprise TJBot or actually other actual full kit. So just for some reference. I'll just take a minute and look at some of the questions that are coming in. See if I can. Okay. Okay, no questions so far. So the next important piece is programming TJBot, setting up. What does that entail? How do you go about that? And there are a bunch of steps. So essentially, when you get your kit, you will either have your Raspberry Pi operating system already pre-installed in your SD card. And the first thing you need to do is to insert your SD card onto your Raspberry Pi, power it on, connect your mouse and your keyboard, and get your Raspberry Pi connected to Wi-Fi. And once that's done, the next thing you want to do is to update the Raspberry Pi software. And right after that, you want to also update the version of Node.js which runs on the Raspberry Pi. It's kind of important that you do that because the version of Node.js that comes with the default Raspberry Pi operating system is a little bit outdated. That's, I think, the version 0.10. And most of the code samples we have available require a more recent version of Node.js, version 6 and above. So it's kind of important that you do that. And I'll go into more details on how you actually go about updating your Raspberry Pi operating system and Node.js. Right after that, the next thing you want to do is to connect your hardware. The first thing you want to do is connect your LED. There's a bunch of instruction on how to do that. You want to connect your servo motor, connect your microphone and your speakers and your camera. The fourth step has to do with going up to BlueMix, creating an account. So for much of what you were prototyping, I expect that most of you will depend on IBM cognitive services, things like speech-to-text, text-to-speech, vision recognition, natural language understanding, retrieve and rank, and so forth. And to get access to these services, you need to go to BlueMix, create accounts there, and get credentials. The next part is that you need to, if you want to start out with the sample code that we've put out there, you need to download and clone the GitHub repository, and you're actually good to go. So I'll just show you guys a link to some of the material we have on GitHub and Instructables. So this is the Instructables homepage. If you use any of the links that I put earlier, it will take you down here. And this kind of shows some of the sample step-by-step instructions that have been created to guide you through the process of building and programming the TJBot. So there's instructions related to building TJBot out of cardboard, instructions on how to 3D print TJBot, instruction on how to run a sample recipe in which you could control the LED on TJBot using your voice, and then some sample instructions on how you could connect TJBot to a Watson conversation instance, and then connect TJBot to Twitter and analyze sentiment and a few other samples. So for today, I'll just walk through the steps that are related to running one of our sample code that's related to controlling the lights on TJBot. So the first thing you want to go through is ensure that you have all the parts that are necessary. The next thing you want to do is to update your Raspberry Pi operating system, like I mentioned. And to do that, you need to go to a terminal on your Raspberry Pi operating system. I think I have a Raspberry Pi instance open up on my screen. And essentially what you can do is come to your terminal here, and then you can run the command sudo apt get install update and upgrade. And each of these commands are available on the step-by-step link we have over here. The first two commands we have over here is just updating the Raspberry Pi operating system. The next command we have here has to do with downloading the latest version of Node.js, which is the runtime environment for all the sample code we've put out for TJBot. And right here is where we install Node.js, and then we install some additional packages that have to do with sound and recording audio and then playing audio. If you haven't already done that, the next step here shows a quick video of how you could assemble the different parts of TJBot, fold the cardboard, put in your Raspberry Pi. The next thing you want to do is to connect your LED. There's actually a wiring diagram which we have, and this kind of labels the different pins on the LED. There's a flat side on the LED, so that kind of gives you an idea of how to orientate and label the pins. So the pin, the longest pin facing the flash side is the ground pin, followed by a 3.3 volt pin, and then followed by a data in pin. And then there's a diagram that shows how each of these different pins are connected to the Raspberry Pi board. I do have a model here, and essentially we have the LED over here, and then there are 3 wires that show how you can connect them to the pins right on your Raspberry Pi inside TJBot. So one thing, it's important that you're a bit careful in how you set up the LED connection. If this is connected incorrectly, that could lead to damaging or popping off your LED light. So it's kind of important that you be a little bit careful with that. So the next thing you want to do is to when you have all of your hardware connected and you updated your Raspberry Pi operating system and also downloaded the latest version of Node.js, the next thing you want to do is to download the sample code on GitHub. And you just open up the GitHub. Essentially, this is the GitHub repository for TJBot. This is the GitHub repository for TJBot, and the files you actually need to pay attention to the most regarding sample code are contained here in recipes. So here we have 3 different recipes. The first one, speech to text here, shows how you could run some sample code that essentially when you talk to the bot, turn on the light, turn off the light, turn the light green, turn the light red. And that's exactly what this sample code does. The second one, sentiment analysis, shows how you could connect TJBot to Twitter and then analyze sentiments around the tweets that come in regarding a given keyword, and then change the color of the LED on TJBot. And the third one, conversation, focuses on how you could connect TJBot to an instance of IBM Watson conversation and modify all of that. So to download the sample code on your Raspberry Pi, essentially you go to the terminal on the Raspberry Pi, and then you run the following commands: git clone. You put in the project, the GitHub project URL, and then when you download that, you can go into the speech to text directory and then run npm install. So what npm install does is that it installs all the dependencies that are required in order to run that particular recipe or that particular code sample. The next interesting and important part that you need to do is to go on to BlueHack and then create credentials. For those who haven't been on BlueHack, the first thing you want to do is that you want to log into BlueHack. Once you're logged in, then you can go ahead and create a new instance of whatever service that you need. In this case, we want to create a new instance of the speech to text service, and then you can create that. And then it will generate a username and a password for you, which you can then integrate into your application. So in order to get your credentials, you go to service credentials over here. And then in order to look at your credentials, you can click view credentials. And directions for that, you can find that also on the GitHub, on the instructables pin then first you create your credentials, and then you select service credentials, and then you can come in, click on your credentials, and then you can have access to your password and username. The next thing you want to do is to take those credentials and then make them available into your sample code. And to do that, the first thing you need to do is each sample code comes with a default config.js file. Config.js is essentially a file where you store some of the configuration parameters you need for your application. And essentially, this is what config.js looks like. It does have a space to it's pretty much a text file, and then it has two parameters here where you can put in your username and password. So whatever password and username you get from IBM Linux, you can then copy those and put them into this file. It's important that you rename the file from config.js, config.default.js to config.js, because this is where, when you run your application, it searches for config.js and then uses that to spin up your speech-to-text instance. And then once you have your credentials set up, the next thing you need to do is to actually run your sample code, and use the command to get that done. Sudo node stt.js. And essentially, for this sample, once you run this, you should be able to speak to the bot and tell it things like turn on the light, turn off the light, and you should be able to get that done. I'll also just walk through the content of stt.js really fast. So going through that piece of code, we have a variable here that says TJBot require TJBot. So TJBot is a library that we developed to make it really simple to program TJBot and to implement a few of its capabilities. So for example, to make the bot listen, to make it see, to make it speak, we've encapsulated most of these functions into single lines. Of course, a few operations happen each time the robot needs to listen. Essentially, it takes audio, sends that to Watson's speech to text, and then gets it transferred back. However, with the TJBot library, we've encapsulated all of that into a single method. The next thing we do is to load up our configuration file, which is the file that we just edited, and put in a username and a password. So essentially, from that file, we get the credentials, config.credentials. Okay, I'm just looking through a couple of questions, and I see a person has asked a question about access to the TJBot library, and that's a good question. If you would go to the GitHub repository, we have an organization called IBM TJBot. And if you scroll down, you'll find the TJBot library is the second repository under that organization. So you could take a look at the library. I think it's a really great way to learn more about how the library works and the different functions and methods that are made available.
We actually have one more question, Victor, which says, the videos for assembling the bot are always sped up. Approximately how long does it take to assemble the bot?
Okay, that's a good question. Thanks for reading that out. So it depends on how comfortable you are with assembling the bot. So it will take anything from, I've done a complete assembly in about 20 minutes, so 20 to 30 minutes. So that's about how much time it does take.
Perfect. We have another question that just came in. Is there a recipe for visual recognition?
We do have one. So if you would go to again, if we go back to the TJBot repository, we have a folder called featured, and here we keep a curated list of different community-based recipes that have been created. And if you will scroll down, you will find a few recipes that show examples on vision recognition. So there is one that I've created, and it's called TJ Vision. If you scroll down, you'll find that yeah, there's a section called vision recognition, and there's something called TJ Vision, and there's some sample done based on the dread, and there's a bit of material there. So this is where you could get more information about vision recognition based samples. Okay.
All right. I think that answers all the questions that we have in there for now.
Okay.
I'm sure we'll have more.
Okay.
Yeah.
That's fine. So I'll just continue with the work through the of the speech to text recipe code file. Here we have a credentials which is imported from our configuration file. The next thing we want to do is we want to specify the different hardware platform, the different hardware devices that we're going to use, which we want instantiated for this recipe. So here we have LED microphone. Other examples could be camera if you want to have access to the camera. It could also be servo motor if you want to move the arm on TJBot. And you can learn more about what these options are by going to the TJBot library link. And then finally, you could set up a couple of other parameters. So for example, if you want to enable login to the console, you can enable that using some additional configuration files here. You could also do other things like set configuration for speaking and listening. So for example, if you wanted to change the voice of your TJBot from a male voice to a female voice, or you wanted to use a different language instead of English, you want to use Spanish or Chinese or Japanese, there are different settings or parameters that you could set on the TJ config in order to get that done. The best place to learn more about this would be to look through the TJBot library, because it does contain documentation on how you can specify all these different parameters. And so these different parameters, credentials, hardware, and config are then used to create a new instance of the TJBot library, which is what we have over here. And the next important piece here is line 52, where you could just say tjbot.listen. So essentially, this is one of the benefits of the TJBot library, and it's a method that gives back, has a callback with the message, the transcript message that comes back. So when you call tjbot.listen, it continues to listen to the microphone and send the audio that it hears down to the Watson speech-to-text API. And whenever there's a message transcript, that message transcript is returned back as a callback over here. And then here, what we just do is that we just do some very simple parsing of that text transcript. And we look for things like turn, change, set, the lights, and all of that. And then decide what we want to do based on that. So we can extract the color that we want to change light to. And in order to set the color on the LED, you can just write tj.shine and you put in the color. Here, this variable will represent things like red, blue, green, as extracted from the voice command that the person is issued. And that's it for the most part on how to listen for audio, get transcript, and then based on that transcript, process it and change the color of the lights and TJBot. Okay, just get back to the slides. So I'll just give a really brief overview of the TJBot library. The goal for this little library is to encapsulate basic functions such as listening, speaking, setting the LED color, waving, and singing. And so, for example, like I mentioned earlier, if you wanted to listen transcript of text that comes in from speech to text. It's a single line of code. Of course, after setting up your configuration file and specifying your hardware configuration, you use TJ.listen and then get transcript as a callback. If you wanted the bot to say something like "Hello, how are you?" you would use TJ.speak, and it will take an argument of the text that you want the robot to speak. Essentially, that's sent down to Watson text to speech, and it synthesizes audio that's downloaded and then played back. But all of that is handled by the TJ.speak method. Also, in order to react to a conversation flow, you use TJ.converse, and essentially in your config.js file, you would have provided parameters for your Watson conversation instance, your conversation workspace ID, your username and password, and whatever text you send to the converse method you send to your conversation instance, and then the response comes back. Similarly, if you wanted TJBot to look around and see, it's the same general approach, tj.c, and then if you want to play some specific sound, tj.play sound, that also takes an argument of the location of the sound file that you want to play. So there are still a few things we're working on regarding TJBot. As you work with it, you will probably notice a few things. Things related to speech accuracy, being able to interrupt the bot, and also issues with network delay and latency. These are open areas. I mean, this is also an invitation to everyone who's working on this project. If you do see opportunities to contribute to the project, ways to make it better, it's a really small team working on this. We really welcome all of that. So at this point, I'd like to pause, and if anyone has specific questions around your hackathon preparation, I think this is a good time to ask just before I end the presentation. Any questions?
We currently don't have any in the panel, but I do want to open it up to our attendees and ask if you do have any questions. Now is the chance. Now is your chance. So please feel free to ask.
Well, while you're waiting there, I wanted to share my screen so you guys could see that one of the things that we've done recently is create the 3D model of TJBot for VR. And we did that with the 3D printed file. So if anyone's interested in doing something with TJBot in VR or in a digital 3D model, we should have this model pretty soon.
Mm-hmm. We just had a question come in. If I want to use a Watson service that isn't in the library, what must be done?
Okay, so that's a really good question. So the short answer is that you can just go ahead and use it like you would use in any other Node.js application. All IBM Watson service do have like a Node.js SDK that allows you easy access to each of these different services. So for the services that are not implemented in TJBot library, no worries, no problems. You could just import the Watson Node SDK for that particular API or service and then use it directly. So for example, in the library, we don't have an implementation for something like natural language understanding. And you could just go ahead and do an npm install for the Watson Developer Cloud SDK that has support for natural language understanding, and you could just use that directly. So there are no restrictions. And also, if you wanted to use the APIs directly without using a library, that's also possible. Okay, I see another question. Any recommended language to program TJBot? Currently, we use JavaScript, which is implemented in Node.js. Node.js is a runtime environment for creating server-side applications written in JavaScript. And we kind of selected Node.js and JavaScript because it's one of the most widely used and easy to learn programming languages out there. However, TJBot is run off of a Raspberry Pi. It runs a Linux operating system. You pretty much can write in any language. You can write in Java, Python, Node.js. I think generally most people would either use Python or JavaScript Node.js, but I think I would suggest Node.js because it just might be easier, and there's a ton of resources out there, especially some of the resources that we've put together, we've curated, and we have this GitHub community that where there's a ton of questions and a bit of documented experience on. But technically speaking, I've seen people who have programmed the TJBot using Python, and some people who have programmed TJBot using Java.
Victor, I've got a question about, like, the 3D printing model. I mean, is there any difference functionally between the 3D printed model and the cardboard one?
So I think the biggest difference you might notice off the bat is that the 3D printed model is less fragile than the cardboard model. So I do have a cardboard model here. I've had it for about 5-6 months now. It still works pretty well, but I imagine if I needed to travel and all of that, I need to be really super careful with it. However, so for something like a 3D printed model, it's more durable. It probably would survive crashes a lot better than what the cardboard model works. But in terms of dimensions and appearance, they're designed to be exactly the same. I think the only thing is that, of course, price and costs. The price for a laser cut cardboard is about $15, and the price for a 3D printed case can vary really widely, depending on where you actually do your 3D printing.
And what about the materials that you can use for the 3D printing? It's all, I mean, is it all kind of plastic bead based, or, I mean?
So far, I've experimented with PLA and ABS. I think those are two primary materials, but I think you can also use other materials like PETG, depending on what your 3D printer can handle. Actually, I think it depends more on what your 3D printer can handle.
Right.
Yeah.
So we got a question that says, which version will we receive during the hackathon?
So from what I know, and this might be subject to correction, I think most people might be receiving a kit, and usually the kits come with a cardboard TJBot that needs to be built.
Perfect. Thank you. All right. We do have Victor with us for a few more minutes, so feel free to ask the questions.
Oh, absolutely.
All right.
Well, I've got a question. Is TJBot just one of the options of something to hack with, or is everyone? I mean, you got to decide that you want to do something around TJBot for the hackathon, right?
It is one of the challenges that they have available to them. So they actually have 4, and TJBot is one of them.
Got it.
Yeah.
So over the past few months, we talked about TJBot for the first time in November last year, and there've been a few pretty interesting applications. We've seen people try to prototype things to try to recognize sign language. I've seen people try to take a challenge like that. You know, TJBot does have a camera in its eye, and there are people that are trying to take pictures of of hand movement in front of it and try to classify that and understand sign language. So that's a really pretty interesting direction I've seen. We've seen a team that designed a financial advisor and put a voice-based interface in front of that on TJBot. So essentially, they had all this domain knowledge and a huge database around financial data and stock portfolios. And essentially, they created a conversation that will guide the person through the process of making a financial decision. So, for example, they will ask the bot like, "Hi, TJBot, I need some help with making a financial decision," and TJBot will say, "What kind of stocks? What area are you interested in? What industry are you interested in?" And they will give response. So essentially, using that voice-based conversation UI, it would extract their preference and then make a recommendation to them. At the workshop earlier, there was a cook who thought that it would be interesting to have a TJBot on his chef. I thought it would be interesting to have a TJBot on his kitchen counter, where he could pick up random cooking ingredient around his kitchen and show that to TJBot, and TJBot will recognize them, and then after a while, TJBot will make a recommendation on what meal to cook. And if it was an ingredient that TJBot had not seen before, TJBot will say, "Okay, turn it around, let me look at different parts of it," and it will on the fly train a vision recognition model, a custom vision recognition model on those images, and then later to recognize that particular object, and then make a recommendation on what to cook. And I think there was a hackathon also a couple of months ago in which an 8-year-old girl came up with the idea of having TJBot as a narrator for kid stories, and essentially it will take a passage and try to read out this passage and then get some feedback from the person and then decide on what other passages to read out the story. But these are some of the interesting applications I've seen over time, and I really look forward to seeing what you guys are going to build during the hackathon.